Myself JV and Dr. Kiran Yadav. In this session I will discuss about common emitter configurations of transistor. This is the most common configuration of transistor. In this, emitter terminal is common to input and output circuits. That is why its name is common emitter configuration. We will look at the characteristics of the device in this configuration. The current relations are still applicable, that is IE is equals to IC plus IB and IC is equals to alpha IE. The common emitter configuration with NPN and PNP transistors are shown in the figure. The first figure is the common emitter configuration of NPN transistor and the second one is the common emitter configuration of PNP transistor. This is the input characteristic curve for the common emitter configuration. IB is the base current and VBE is the voltage across base and emitters terminals. The input takes the form of forward biased PN junction. The input characteristics are therefore similar to those of a semiconductor diode. An input current IP is a function of an input voltage VBE for various output voltages VCE. The curves are at different values of VCE. Like the orange one is at 1 volt. For the green one, the value of VCE is 10 volt. And for the pink one, the value of VCE is 20 volt. This is the output characteristic curve for the common emitter transistor. IC is the collector current, VCE is the output voltage. There are three regions. Saturation region is shown in yellow, cutoff region is shown in pink color and the active region is shown in green color. The various curves are for different values of IB. Okay, so the uppermost curve is for IB is equals to 80 microampere and the lower curve is for 0 microampere IB value. The magnitude of IB is in microampere and not as horizontal as IE. In common base circuit, the output set relates an output current IC to an output voltage VCE for various of level of input current IB. There are three portions as shown. First one is the active region. The active region located at upper right quadrant has the greatest linearity. The curve for IB are nearly straight and equally spaced. In active region, the BE junction is forward bias whereas the CB junction is reverse bias. The active region can be employed for voltage, current or power amplification. Second is the cutoff region. The region below IB is equals to 0 microampere is defined as cutoff region. For linear amplification, cutoff region should be avoided. The third is the saturation region. The small portion near the ordinate is the saturation region, which should be avoided for linear application. In the DC mode, the levels of IC and IB at the operation point are related by normally beta range from 50 to 400. So beta DC is equals to IC upon IP. For AC situations, beta is defined as. The proper biasing is essential to place the device in the active region. A common emitter amplifier of a PNP transistor is shown in the figure. The first step is to indicate the direction of IE as established by the arrow in the transistor symbol. The other current IB and IC are introduced, satisfying IC plus IB is equals to IE. The supplies are introduced with polarities that will support the resulting direction of IB and IC. If the transistor is a NPN transistor, all the current and polarities would be reversed. That's all about the common emitter transistor. In the next session, I will discuss about the common collector configuration. Thank you.